So welcome to our free JavaScript class. I'm really glad you're here. I am, in fact, Erik Gross. This is me. We need to get a little more current picture that shows that I got a little more gray, but at least I'm smiling and happy in this picture. I've been an engineer, a developer for a long time. So while there's no official rankings of software engineers, you can call me a senior level software developer. Um, at this point, there's a lot of little names you could put after it. I've done most things there are to do in technology. Years ago, a lot of my engineering training and stuff came from my experience in the Navy. I was a nuclear reactor operator, electronics technician, and did a lot of work with digital computers and a bunch of nerdy stuff there. And I'm the co-founder of the Tech Academy, the group that puts these free classes on. And I'm really glad to be here today. I hope you get a lot out of it. All right, a couple basic guidelines for the class. We have an assistant in the class monitoring the chat, answering questions. Feel free to use the chat. Love that. Whoa, Ludovico. Okay, this is okay. Totally not part of the class. Have to share this. Ludovico says, "Did you know that the pistachio industry lobbied the U.S. to continue the Iraq War so they could corner the market?" That doesn't shock me at all. In fact, we think oil rules the world. We just found out pistachios rule the world to a certain extent. That's excellent. Okay, good. So another quick thing about this, I almost feel like we don't even need to say this because it's been so long since we had anybody who was a jerk in these classes, but be nice. Our assistant will remove you if you're a problematic student, but we have great people that attend these classes. I do want to stress that certain aspects of this class, because it is a practical class, you'll be following along and actually writing code, creating a computer program. Part of it will be challenging. You might run into challenges as part of this. Part of the learning process, any learning process, but particularly coding, is working through challenges. So use chat as needed. I try to make this as easy to follow as possible. One key thing is whatever I write on the screen, write that code that I write exactly as it's written. It's an interesting thing about code that a misspelled word or a missing symbol or even something capitalized that shouldn't be capitalized can result in errors in your code. And there's a reason why. We get into a little bit of that in this class, but just make sure you try to follow along exactly in terms of the spelling and formatting of what we put in as code. I always like to share this. This is my favorite coffee mug. That's a Hobbit door on a coffee mug. Okay, good. So let's move on. This is a real key thing. Every once in a while, we get people attending on a mobile device. I don't see any notifications in the Zoom attendees list that anybody's joining us from a mobile phone. But if you are, it's real hard to do the coding, but you can listen, and you're still going to learn a lot from it. A key thing. Hi, George. Glad you're here. Please make sure you're in a distraction-free environment. We put these on so that people can get really real value out of them, and part of that value is being able to have your concentration fully on what we teach. So make sure you're in a distraction-free environment, focus on the class, and I don't want to lose you. Finally, while I do try to move at a pace so you can follow along in terms of writing the code, if you fall behind, it's totally fine. Just keep listening and learning because you'll still learn a lot, even if you lose track of where we are in the code. This class is recorded, as you probably had to click the notification for, and the video for it will go up on YouTube. We have a free educational resource playlist on our YouTube channel. It'll be either today or tomorrow that they go up. And you will get the full code for the game that we're going to create at the end of the class. You'll be able to play the game, and you'll be able to tweak the code if you want to, which is kind of fun. And lastly, we provide links at the end of the class for all sorts of things, future events, all these free videos, other resources. So stick around for that. And stick around because we do, in fact, have a free gift at the end of the class. All right. So obviously, everybody's comfortable using chat. It's been really awesome. You guys have been pinging in and letting us know where you're joining us from. Any questions you have, throw them in there. If my assistant can answer them while we're delivering the class, great. If not, we usually have time for a brief Q&A at the end, and we'll try to pick up any questions that haven't been answered. Hello, Will. All right, so this is the basic agenda. We'll have a short explanation of the Tech Academy. Then we're going to spend the bulk of the time writing code. And that's where the bulk of the learning will happen. As I said, we'll have a brief Q&A session at the end. We'll cover some information about the Tech Academy and our boot camps, in particular, how we teach, getting people into technology in a successful manner so that they're well equipped for a long-term career requires a certain approach, and we'll cover what that is. And like I said, there's a free gift at the end, so stick around. Whole class will take about an hour and a half. All right, so quick introduction to the Tech Academy. First of all, what we deliver are coding boot camps. And a coding boot camp, most of you are familiar, but if you're not, it's an intensive technology certification program designed to prepare people for entry-level positions in the technology industry. These programs, and not just ours, but there's a number of providers, they typically last 3 to 6 months, and they focus on practical, modern skills. Boot camps, by the way, are one of the 3 general routes into the technology industry. You can go, university and college, get a computer science or related degree. You can self-study, or you can do a boot camp. And those are the 3 basic ways to break into this industry. At this point, we've been offering thorough, budget-friendly, flexible, and trusted coding boot camps for over a decade. In fact, this evening, you'll have a link to it later on. This evening, we're having a huge, wonderful online event celebrating our 10-year anniversary. We're very, very happy with that. Another thing about our certification programs is that they're cost-effective and they're self-paced online coding boot camps. They're tailored for beginners, for people that have no prior technical or coding knowledge. So as long as you're reasonably bright, can read, write, and do basic math, you can get through our programs and break into the industry. My assistant has just dropped into chat a link specifically for that 10-year anniversary event. I'll have more to say about that later on, but I highly recommend you come to that event. Beyond the fact that it'll be entertaining and cool, some really great behind-the-scenes stories of our history, we have a phenomenal announcement. If you're trying to break into technology, you're at the beginning of that technology journey, you're already working in tech, we have a really cool announcement at that event tonight. One last thing about a couple last things about our programs. They thoroughly cover in-demand skills for the tech industry. It's what people are being hired for now. Our programs are endorsed by stellar online reviews. And probably most importantly, they're designed to fit around your personal schedule. They're flexible in that regard, and they prepare you for your tech career with a really well-rounded toolkit. The average cost for boot camps is, the average cost of boot camps in America is $13,500. Our programs are under the national average, and they even start as low as $5,300. And finally, I always like to state our mission statement here, because it's why we do what we do. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry, and whose actions raise industry standards and surpass client expectations. We like to say that our product is you working in tech. All right, now, before we dive into coding, I want to cover a couple of key basic definitions. The first one is a program. And a program is a series of written instructions that are entered into the computer by someone like you, by a technology professional. They're written instructions entered into the computer that make that computer perform specific tasks. That's what a program is. A programming language is an organized system of words and phrases and symbols that allow you to communicate with the computer. This is how you enter the instructions in. This is what tells the computer what to do. Programming languages are used to create these computer programs. And finally, there's this verb, coding. Coding is the act of putting those instructions in, putting instructions into the computer to make them perform whatever function you're trying to create, right? Code, as a noun, is those instructions themselves. So when you're writing code, these instructions, you could say that you are coding. All right, those are basic instructions or basic definitions. Now, let's talk about definitions for this class in particular. The programming language we utilize is called JavaScript. Probably you've heard of JavaScript. About 10 or 15 years ago, it wasn't nearly as popular as it is now. It's now extremely popular, very, very powerful, and it's been around for a long time. It was created in 1995 at the very beginning of the popularity of the World Wide Web. And it can be used for a lot of things. Initially, it was used to add functionality to websites. but is now really versatile. You can use it to create all sorts of programs. Another language you're going to want to know, or sorry, another term you're going to want to know is HTML. It stands for Hypertext Markup Language. A brief note on that. When you're creating a web page, we all know that one of the cool things about web pages is there's links on the page that can, if you click on them, take you somewhere else, take you to another page, right? That's what hypertext is. Hyper means beyond or above. So anything, whether it's words or a picture or whatever, anything on a web page that if you click on it, takes you somewhere else, we call that hypertext. Markup language is a way to control the appearance of things on a page, things on a web page. So whether you're going to bold some text or put an image in an outline or make something flash on the screen, or God forbid, cause a video to autoplay when someone arrives at your page. Never do that, right? All of these things are controlled. Those are called markup. So you take hypertext markup language. This is the language you make web pages in. Another key term here is CSS. It stands for Cascading Style Sheets. A style sheet is really simple. It's just a file where you put a bunch of instructions that control the appearance of things on a web page. That's all a style sheet is. One central place to control the appearance of things on a web page. Cascading style sheets are a technology that let you make a change to how things might appear, and it doesn't just affect one page on a website. That little change you made ripples out or cascades and affects multiple pages on the website, or even all pages on the website. Let's say, for example, at the top of every page, you've got a little navigation area that has all the links, right? We see this all the time on websites. Let's say you want the background of that to be different, the color, the background color. You could change that in one place, and now instantly, every single page on your website that makes use of that little navigation bar, that background color changes. It makes it really easy to manage large websites. All right, so the three technologies you see on the screen are referred to very casually as the holy trinity of web development. These are the primary tools you use to work in the website development area. Now, this is a JavaScript class. So the code we're going to write is in the JavaScript language. But now this part's really important. Even though we happen to be using JavaScript as a language, the concepts we are going to teach apply to any programming language you will ever learn. So even if you're not intending maybe to break into technology as with JavaScript as your primary language, this is still incredibly useful information. All right, now, this next thing I'm going to present is why what we're going to teach will apply to any programming language. It's because we happen to be using JavaScript to teach you about one of the most important aspects or important concepts in computer programming, which is what are the things that make up a computer program? Any program written in any language, what are the 5 things that you have to make use of in any program? And we're going to cover those briefly. The first one is an entrance point. It says there on the slide, first instruction. When you start up any computer program, Microsoft Word, a video game you're playing on your computer, anything, the computer needs to know, where do I start in running this program? What's the first instruction? This is important for a lot of reasons. You learn that in detail on our boot camps, but the short version of this is that when you're trying to figure out how a program works that you've been given, right? It can be very, very helpful to find the first instruction or instructions that get performed as soon as that program starts. And the reason that's valuable is from that point, you can start to trace through the logic of what does this program do in order. If you try to do that midstream, halfway through the program running, you lack a lot of context. It can be difficult. So knowing how to find the first instruction is very valuable. The second element that any computer program will have to make use of is what are called variables. Variables, well, look, any computer program has to keep track of data. I can't imagine a program you would make that wouldn't keep track of data in some way. Whether that data is the inventory items that your computer system's tracking, financial transactions that have occurred, Whatever the problems you're trying to solve, they involve data. Often, the data that your program is working with will change as you continue to use the program. For example, if your computer program keeps track of financial transactions, say at a bank, while you're using the program, more transactions might occur. And that way, the total number of transactions, for example, on a bank account will increase while you're using the program. So your program has to have a way to keep track of data that can change as the program runs. There are pieces of data that won't change as the program runs, but a lot of the data we work with will change, and you need a way to keep track of that. You do that with a mechanism called variables. Another vital element of any computer program is to be able to have control and branching functions. Think of the idea of having two or more possible courses of action that could occur. This happens all the time in real life. It happens in computers. You need a way to be able to make a decision about which one of two or more available courses of action that you've created in your program will occur. That's where the control aspect comes in. We need to control what occurs. The two or more possible courses of action are called branches. It's a branch of your code. And so every computer program needs to make use of this mechanism in some way, shape, or form. And finally, this one's a lot of fun. There's two more, but this one's a lot of fun. We're going to build some of these today. Any useful program will make use of what we call subprograms. These are programs within programs. Now, that may sound like the movie Inception, but let's explain that a little bit. When you're writing a program, and you'll see this today, when you're writing a computer program, it's highly likely that you're going to find there's certain steps, certain like little series of instructions that you're going to perform over and over and over again as your computer program runs. Let's take, for example, updating the list of transactions that have occurred in a bank account, right? You might want to do that, say, every minute or so as someone's using a computer program around a bank. Well, it probably takes several steps, several instructions to accomplish that, to gather a current list of all the transactions, format them properly, display them and display them on the screen. That might take 5 or 6 or 7 instructions. Well, it's really helpful to be able to write that series of instructions one time, and then every time you need to do that in your program, just use that pre-made set of instructions. That pre-made set of instructions is called a subprogram. And finally, the last element that needs to be there in any computer program is an exit. Your program needs a way to inform the computer that the program is running on that the program is done. It's no longer performing any actions. It's no longer needed. Why is this important? Well, there's a lot of detail here. And again, you learn the ins and outs of this in great detail on our boot camps. But the short version is this. While a program is running on a computer, that computer that it's running on is doing a lot of things that are of service to your computer program. One of the simplest ones to think with is that your program is going to keep track of a lot of data, and that data is going to take up space in the data storage element of your computer. They call that part of a computer the memory. The memory is a physical device in a computer where it keeps track of data. Well, there's only a finite amount of it. So while your computer is running, it's taking up a certain amount of the space of that available memory area. It's an actual device in your computer. And like I said, it has a finite number of places it can store data. And some of them are being taken up by your program, so they're not available for other programs to use. So we need a way to let the computer know, hey, program X is done running. You can now make more of the memory available for other computers. It's just one example. There are several reasons why you want to let your computer know, I'm done running this program. So on the screen here, you see the 5 elements that are present in any computer program. Now, I want to stress 2 things before we go on. The first one is that these are not listed in any particular order. And what I mean by that is when you're creating a program, you don't lay out the program in this exact order. What I'm saying is that in a program, these are the different things you use to make the program work. And they come in varied order. The second thing is there's nothing else. There are no other things that are present in a computer program. These are the 5 things that we make use of in any computer program written in any language. Why is that important? Because if you learn these 5 things, it gives you a mental framework to think with. One, learning how to create programs. You have a skeleton in your head of the different types of things you might use to build a program. And 2, when you are given a computer program, let's say you get into tech and you are given a program that you're expected to help maintain or add new functions to, it's this mental framework right in front of you that lets you go through that new, probably large and complex program and start to figure out, what does it do? How does it work? What was the thought process behind the people that created it? This mental framework is helpful because you'll only find these things in that program. All right, now we're going to move on to coding, and we're going to need a place to write our code. The place you write code is called a code editor. Now, my assistant has just dropped into chat a link to a code editor that we're going to use while we do this class. So go ahead and click on that link right now. I'm going to do the same thing. Now, what you'll see on the screen is what I see. On the left is actual code. This is HTML and JavaScript. The HTML is things like, here's a paragraph. Here's a paragraph. Here's a heading. That's HTML. Remember, hypertext markup language, it controls the appearance of things on the screen. Notice, by the way, that this text that says my heading, it's larger than anything else when it gets displayed. And that's what you see on the right, by the way, is the resulting effect of your code. When we run this code on the left, what it does appears on the right. Here's your code editor. Pretty simple concept, but I just want to explain what we're looking at, right? So the JavaScript part is all of this. It happens to be between these 2 script things. This thing, by the way, that I'm highlighting is called a tag. It's part of HTML. It's not that important that you remember it, but it's called a tag. You can see that there's 2 sort of matched tags. And what they're saying is to the computer, hey, everything in between these 2 tags is JavaScript code. So that's what you're looking at. Now, we're not going to use this code. We're going to write our own, but I just want you to have an understanding of what we're looking at. Now, the next thing, and this is really important. While we're coding, I want you to be able to see on the left-hand side of your screen what I'm writing, and on the right-hand side, your own code editor. So let me show you how you do that. You want to set up a split screen. Like I said, on the left will be the instructor's code. Now, what that really means is on the left will be your Zoom program, because your Zoom program right now is showing my screen. So you want to be able to drag your Zoom program off to the left. And on the right-hand side, grab your web browser that has this code editor in it. By the way, if you have 2 monitors, you can just use separate monitors on this. It makes it nice and easy. But this is an ideal way to be able to see both things side by side. So sometimes when you set that up, Zoom doesn't like to cooperate. It won't get small and let you move it around and put it on the left-hand side of the screen. You can sometimes click on this word that says Zoom, or this little thing that says Zoom meeting, and this little restore button will appear. When you click on that, it'll make your Zoom window a little bit smaller. You can move it around and resize it. But the end product, by the way, is on the right is your browser, and on the left is your code. All right, now we're going to get into the actual coding. Give me a moment here to set up my screen. All right, let me share my screen now. All right, now again, make sure you're set up well so that I'm on the left-hand side. You can see right here, this is me. I want you to be able to have me on the left-hand side, and on the right-hand side is your own code editor. Okay, now the first thing is that we're going to be writing in JavaScript. Thankfully, this whole thing is all set up to let you start to write some JavaScript. This next part is super important. If you don't follow this next thing correctly, it makes it really hard to write your code and get it to do output. We want to take away everything that is between these two script tags I was talking about. So delete these 4 lines that I have highlighted. And now you have an empty space to start writing your code. I'll take a moment for people to do that. All right, so let's go to get started. So we talked about one of the key elements, 5 key elements of any program is an entrance point. We need a first instruction. Well, most programming languages work this way. You start writing your code 1 line at a time, and it's not rocket science. The first instruction you write at the top of the page will be the first instruction. So let's make an instruction. This one's going to be really simple. We're just going to make an alert appear. Now, an alert, you've probably all seen this as you've used the web. It's just a little box that pops up almost in front of the web page with a little message in it. So in JavaScript, when you're working on websites, the instruction to make that little thing pop up is really simple. You type alert, A-L-E-R-T. Now, the next thing you want to do is you want to be able to alert, by the way, is a built-in function inside of JavaScript. It's a built-in instruction that we call a function. When you are going to make use of a function, you very often need to give it some information to work with. In this case, this function called alert, we're going to give it some text that's going to appear in the box that pops up. When you're giving a function some information, you put that information inside of parentheses. So without hitting the space bar right after the T in alert, just do an open parentheses. Now we're going to match that with a closed parentheses in a moment. But for now, the next thing we need to do is tell it what text should appear. The text often can appear inside of double quotes. So the double quote is usually to the left of your enter key. You'll need to hit shift, and there's your double quote. Now, we're going to match that with another double quote in a moment. And everything in between the double quotes is what will pop up in the alert, in this little box. So we're going to say, hello, exclamation point, welcome to the snake game. Because we're going to be building a snake game. So I'll let you get caught up there. Now, before I have you write another line of code at all, I want to cover a real important thing. Computers can't think. In general, one of the things you do to make a computer do its job is you give it information that is written down in a specific pattern. And there's lots of different patterns, but one of the more common ones is that if you're giving a computer program some text information, letters and numbers and such to work with, that information, if it's in between 2 quotes, that's a pattern. So you can tell a computer, hey, listen, if you find a double quote, let me show you where the first one is. Here's a double quote. If you find a double quote, Mr. Computer, I want you to move forward 1 character at a time until you find another double quote. And then grab everything you found in between, and that chunk of information is to be used in some way. It's text information. That's a pattern. Well, another pattern, I've already discussed it, is to have an open parentheses, and now go to the end and write this, a close parentheses. This pattern works this way. Hey, Mr. Computer, there's this instruction called alert. You, Mr. Computer, happen to know what that means because you have JavaScript built into you. And Mr. Computer, the way this is going to work is, as soon as you see this instruction that says alert, I want you to move forward and find an open parentheses. And then move forward until you find a matching closed parentheses. Everything inside of those parentheses is information that you need to give to this function called alert. And so you can see there's patterns at work here. Well, we have a pattern here. We have a full instruction. We are telling the JavaScript language, perform a function called alert, take all of the information inside of the parentheses and give it to this function called alert. And I want you to run this and you'll see what happens. It pops up an alert. And notice that the content inside that is exactly what you put inside of the parentheses. Inside those open and closed parentheses. You'll see this pattern all the time as you write computer programs, where you have a function you're going to want to run, and you need to give it some information to do its job. Very often, in most computer languages, that information you're going to give it is to be put inside of parentheses. So it's just a pattern to look for. So we now have performed a first instruction. You can click on OK to make that go away. Let me go ahead and make this text a little bit larger so you can all see it a little more easily. Let's run it again. And you see, it works. All right, so now we have our first instruction. That's great. Go to the end of that line after snake game and hit enter. And let's work on another instruction or two. We talked about variables. Again, this is a way your computer program can keep track of data that might change while the program is running. Well, we're going to be creating a snake game. And this snake game, you've all seen it before. In fact, I'm going to run it right now. Watch this. Don't do this. Okay, just watch what happens here. Don't change anything on your end. I need to make my whole screen smaller in order to have you see all this. This is the full program that we're going to give you at the end of the day, by the way. I'm going to run it. And I think I need to go even smaller. There it is. Look on the right here. And notice we have a little snake game running. I have the little green bar. That's my snake. And he needs to eat fruit. If I use my arrow keys, I can control the snake. Now, let me see if I can get this fruit. See if Erik can actually play a video game. Oh, I didn't do it. Hey, I got it. And now my snake gets longer. It's a snake game. We've all played it before, or maybe you haven't, but way back in the olden times, there was a really, really popular mobile phone called the Nokia that was virtually indestructible and came pre-programmed with this snake game. So that's the game we have. So all that said, let's go back to where the code was. All right, so we're back to where we were. I'm going to run this and, oh, look, I have my alert pop up. And I'm going to make it larger so you can read it. Well, if this is the kind of game we're going to use, as we're learning about variables, let's use some variables that make sense in that context. So as an example, we have two things on the screen when the game was running. We have a snake and we have a piece of fruit that the snake's going to eat. I don't know why snakes eat fruit. I don't think that's true in real life. But regardless, we didn't want to say a mouse because that's just horrible. So we need a way of keeping track of where is the piece of fruit on the screen. Now, the actual logic to do this is a little more complex than what we're going to do, but this just illustrates the concept. Again, go right on the line after your alert instruction, and let's make a variable that will hold information. And that information is going to be, what's the position of the piece of fruit? The way you make a variable in JavaScript is relatively simple. You come up with a name for the variable, and it should be a name that communicates well. You don't want a variable name for the position of the fruit that's just named F. All by itself, F. That doesn't communicate a lot. Let's make the variable name be fruit position. So type F. It starts with the lowercase here, RUIT. And now do a capital P for position, POSITION. That's the name of our variable. And that's all it takes to make a variable in JavaScript. Let's hit space. Now, it's real important to understand what's occurred here. When JavaScript runs this particular instruction, fruit position, it's a one-word instruction. All that actually occurs is JavaScript tells the computer, hey, find one of those memory locations that's in the devices inside the computer. Find one of those locations and give it a name. Name one of those locations. It's going to be called fruit position. And the computer says, okay, I did that. I found a memory location and I named it fruit position. That, by the way, is called declaring the variable. You said, hey, there's a variable. It's going to hold some data. What we haven't done is put any data in that place in memory. It's just blank right now. There's no information. Well, we're going to have it store some information, and that information is going to be the position of the piece of fruit. In JavaScript, the way you put data into one of these variables is you use a symbol that's this equals sign. So type that equals sign and then hit space. That symbol is an instruction to the computer to take whatever's to the right of the equals sign. Now, we haven't typed anything yet, but whatever we type to the right of the equals sign, we're going to take that data and we're going to put it in that actual memory location that we have called fruit position. We're going to put in the number 100. That's supposed to be a location. So do that. And by the way, JavaScript does like it if at the end of every instruction you put a semicolon. So let's put a semicolon there. I forgot one on the line up above. So let's go to the end there and put a semicolon. The people that make JavaScript make it flexible enough that if you forget the semicolon, it generally works okay. But let's do it the right way. So now we have a variable. We have declared the variable by giving it a name, and we have assigned it a value by putting something after the equals symbol. And those are the two verbs, by the way. We declare the variable and we assign it a value. This pattern, by the way, is common in almost all programming languages because, as I said, variables are one of the 5 basic elements of any computer program. This is how you do it in JavaScript. Fine. So it's there. Well, we want to make use of it. Why don't we print in an alert what the current position of the fruit is? So hit enter. And if you've been following along, you should probably be able to do most of this. We're going to do an alert. So type ALERT. Remember, an alert function needs some information. It needs to know what to put in the alert. So give yourself an open parentheses. And we're going to type in some text. So give a double quote. And we're going to say fruit position, colon. And right after this, we're going to make that number 100 appear. But the way we're going to do it is we aren't going to type in 100. Instead, we want the current value of the variable called fruit position to be used. Here's how you do that in JavaScript. The text that we put down so far will be the same every time we use this particular thing. But the value of fruit position might vary. That's the whole point, is having a variable named piece of data. How do you do this? Well, give another double quote. We're done with our text, but now we can add in, immediately following this text, please display the current value of the variable fruit position. You do that in JavaScript by going, give a space and do a plus symbol. And then just type in the name of the variable you want to use. So we're going to do fruit position, F-R-U-I-T, capital P. Remember to type in it exactly the way I'm doing it, O-S-I-T-I-O-N. And now that's all the information the alert function needs. So we're going to do an open parentheses. That's the end of our instruction. So do a semicolon. Now, let's have a little fun here. Don't run it yet. Don't run it. I'm going to open up the chat. And I would like you to pop into chat. What do you think is going to display in the alert? Type out exactly what you think will display in the alert when we run this. If you've already run it, don't cheat. But if you haven't run it, type in there, what do you think is going to appear? Come on, someone take, oh, there we go. Fruit position 100. Ah, Iman wins the prize. Okay, so here's what Iman said. He said what's going to print in that alert is, well, he's close. It says, hello, welcome to the snake game, fruit position 100. Now, Iman, you win some bonus points here, and I'll tell you why. The first alert will say, hello, welcome to the snake game. And once we close that alert, another alert will come that says fruit position, space 100. So let's run it. And there's the first one. Hello, welcome to the snake game. When you say okay, another one appears that says fruit position, space 100. Because we performed these in the order they're presented in the code. All right, fine. Click OK to make that go away. Well, the whole point of a variable is it keeps track of data that can change. Let's pretend the fruit is at a different position. Make another line, and let's change the fruit position value. You do that by just calling out the name of the variable, fruit position, and then do another assignment symbol. The equals is called the assignment symbol. We're going to assign it a new value, and let's make it 200, and then do a semicolon. Now, don't run it. Don't run the code. Please put into chat, what do you think is going to appear and in what order when we run this? Take your time writing this out. Think it through. What's going to appear and in what order? George says fruit position 100 and then fruit position 200, but he's got a question mark, which is good. Anyone else take a stab at what you think is going to happen here? Fatima says, hello, welcome to the snake game, and then fruit position 100, which is correct. Ludovico says the same as before, which is correct. Now, let's do it, and then I'll explain what's going on. Okay, let's run it. There's our first alert. It says, welcome to the snake game. When we hit OK, the second alert, fruit position 100, and you click OK, and we're done. Now, why didn't it say fruit position 200? This is actually really important. Computers can only do one thing at a time. And when you create a program, you create it one instruction at a time, and it starts at the top and moves through. So let's look at this as if we're the computer. Let's read one instruction at a time. This is the first instruction. And so it performs that instruction. We saw that. It made an alert come up. The computer, once it's done doing that, like when you've clicked the OK button on the alert box, only then does the computer go on and say, okay, what's the next thing to do? Oh, I'm creating a variable called fruit position, and I'm assigning it a value of 100. And it does that. As soon as it's done doing that, it goes on to the next instruction. Oh, I'm going to make an alert appear that says fruit position and then displays the current value of the variable fruit position. The current value at that exact moment in time is still 100 because the computer isn't going to read ahead. It's only doing one thing at a time. So then when we get to this alert and we click OK, only now does the computer go, oh, I'm done with that. Let me go on to the next instruction. And it assigns a new value to the variable fruit position. But we haven't popped that up an alert. You can do that right now. Let's make it easy and just copy this line, go after the line where we assign a new value to fruit position variable, paste it in, and now run it. You'll get 3 alert boxes. Let's run. There's our first alert box. Hello, welcome to the snake game. We click OK. There's our second alert box, fruit position 100. Okay, good. Click OK. Third alert box, fruit position 200. All right. Shane says I only get 1. So Shane, take a look at the exact formatting here. Make sure that semicolons, by the way, aren't vital, but make sure that you've written these 5 lines, 1, 2, 3, 4, 5, in this exact order. And that you have made the names of the variables correct. Make sure that there's no space after the word alert and before the opening parenthesis. Those are some things to look for. All right, so now we've covered an entrance point. We know the first instruction that we'll execute. We covered variables because we made a variable and gave it a value, and then we changed the value on that variable, and we were able to make use of the new value. That's pretty cool. Now let's go on to control and branching statements. Now, one of the common things we're going to want to check inside this program is, has the snake found the fruit? And we have 2 possible things to happen. Every single time that snake moves, we need to check, has the snake found the piece of fruit? If it hasn't, then the snake keeps moving in the same direction and it does not grow. But if the snake has found the fruit, then it grows, it gets longer. This is a perfect example of control and branching. We have 2 branches, 2 possible things that could occur, which means 2 sections of code. We'll only run one of them if a certain condition is met, i.e., the snake did not find the fruit, and another branch of code that'll run if the snake does in fact find the fruit. This is a control and branching situation. So the instruction in JavaScript to make something like this happen is using an instruction called if. With the if instruction, we can check to see whether or not a particular condition is true. If it's true, then we would do one thing. If it's false, then we do another. Well, we know what the situation is that we want to care about. We care about, has the snake found the fruit? Well, before we write this, we're missing a piece of information. We happen to be keeping track of where the fruit is, but we're not yet keeping track of where the snake is. Clearly, the position of the snake is a piece of data that can change as the computer program runs. We saw it. The snake is constantly moving. So we need a variable to keep track of the snake position. because variables are for data that will change as the program runs. So let's make a new variable for the snake position. I think you can all see what we're going to name it. We're going to name it. I'm going to give myself a hit enter just to make a little space for readability. Snake position, lowercase s-n-a-k-e. Let's do a capital P-O-S-I-T-O-N. And by the way, capitalizing the P when you create your variable isn't required. It just makes it easier to read. But if you have named it in a certain way with this capital P, you have to use that same spelling in the future because that's the exact name of that variable. So we've made a variable called snake position. Awesome. We've only declared the variable. To reiterate, all we've done so far with what we have written on this line is we've told the computer to find a location in its memory and name that location snake position. We have not put data in that place in memory. We have not assigned it a value. Hit a space, use the assignment instruction, which is the equal sign. Hit a space, and now let's give it some data. Let's say this is at position 500. It's a long way away from the fruit. Nowhere near the fruit. Hit a semicolon, hit enter, and we're done. So we've now created a variable. We have two very useful variables. These are the two things we need to keep track of in our computer program. Where's the fruit? Where's the snake? Good. So now we can set up a control situation. We can start to control one of two or more possible actions based on whether or not the snake has found the fruit. You do that, as I said, with the instruction if. So let's type if. This is another instruction in JavaScript where you have to give it some information. Now, let's pause for a moment here. This is pretty important. The information we need to give this instruction called if, the information we need to give it is something that is either true or false. Not a maybe, not a kind of. It's either 100% true or it's 100% false. That's called a condition. And you give the condition to this if instruction, big shock, inside of parentheses. So let's give ourselves an open parentheses. Now, in order to check whether or not something's true, there's a very common methodology in JavaScript and lots of other languages to check for equality, to give two pieces of data and have the computer determine, are these two things identical? Which is what we're doing right here. We want to find out, is the fruit position equal to the snake position? If they are, then we know our snake found the fruit. So because we have these two variables, we can compare whether at the exact moment that this if instruction is performed, we can compare whether or not those two variables have the same value. You do that by writing out the two variables and putting a special symbol in between them that checks for equality. So let's write out the first position. We'll say fruit, or the first variable, say fruit position. Make sure you spell it exactly the way you spelled it when you made the variable. That's the first one. And now we put in this special symbol that tells the computer to check for equality. It is two equal symbols, one after the other. To the computer, that is a completely different symbol than the single equals here. The single equal symbols we already covered. It's an instruction to the computer to assign a value. Take the variable to the left of this symbol and the data to the right. And this symbol says, assign the variable to the right. Assign the value on the right to the variable on the left. That's what this symbol means. The double equals is completely different. Yes, I know they look very similar, but you can make the computer interpret them differently. And the way, again, that this is interpreted is this symbol, two equal signs side by side, means take the two pieces of data on either side of this symbol and determine whether or not they are identical. So we need a space and we need our second piece of data. That's the snake position, S-N-A-K-E, let's make sure you capitalize it, POSITION. That's our condition that we need to check for. And since we're done with the condition, we can do the close parentheses. And now you can see this full instruction. This is a control instruction. We're taking this if function and we're giving it a condition that is capable of being checked for equality. Now, fine, that's the control. What about the branching? We now need at least two things that will occur. One of them will occur if this condition is true. One of them will occur if the condition is false. Let's do the true one first. The way you do that is you put the instructions that will be done. If this is true, you put them inside of curly brackets. So hit a space and give yourself a curly bracket. It's right above the square bracket on your keyboard. It looks like that. Now hit enter twice and then do the end curly bracket. You see how they go different ways. Every instruction that you put inside of those curly brackets will be performed only if this condition is true. Well, what do we want to do if the condition is true? Well, we want to make the snake longer, don't we? Now, we're not going to program out all the instructions for that. We're just going to use a simple thing where we're going to pop up an alert that says, the snake is bigger now. In the real game, which we'll review after this, you'll see there's a little more logic there on making the snake longer. We're not going to get into all that. I just want you to understand the way to control the computer's performing either one set of instructions or another set of instructions based on a condition that you can check. So let's put down something that will occur if the fruit position value and the snake position value are in fact identical. And that's why the cursor is now right in this empty space here. Now, for readability's sake, I want you to hit the tab key once, and that's going to move the cursor over. It just makes it easier to read this instruction that's going to be done if the values are equal. What do we want to have happen? Like I said, we're going to have an alert pop up, ALERT, and make sure you have your open parentheses, and we're going to tell it what to say. So do a double quote. Found the fruit, period, snake gets bigger. And then do your end double quote. And now that's all we want to do. So hit a close parentheses. Will asks if we'll be able to see recording. Absolutely. We put all these up on our YouTube channel. If can I have my assistant drop the link to our link tree in there? Everybody's going to get this later on, okay? But you'll find a link in there for all of our free classes, and this recording should go up in about a day. All right, good. So thank you so much. All right, so we're talking about control and branching. We've got our control part. That's this section of code. And we have one branch. We know what to do if these are equal. So before anybody runs this, I'd like you to tell me in the chat whether or not this alert will pop up when we run it. Yes or no? Yep, Iman says it will not pop. Okay. Okay, now again, don't run it. What if I go here and I do that? Will it run? Why is the 0 not appearing? Oh, I hit insert. Okay. Will the alert pop up now? Absolutely, it will. So go ahead and run it. There's our first alert from our first instruction. Click OK. Here's our second alert when we created the variable fruit position for the first time. Click OK. Here's our third alert when we change the position to 200. And then here's this alert because this condition right here was true. All right, click OK. Well, now we need something to do if it's not true. You do that with a special instruction called else. So go to the end after this last curly bracket, do a space, and then type the JavaScript instruction else. Notice that our code editor, by the way, makes the color of the text blue. That doesn't do anything special except make it easier for you to read your code. The code editor we're using does that for you automatically. It's all about readability of your code. You'll notice it's been doing that all along. And you can see it does make the code a lot easier than if all the text were black. But it doesn't change how the program runs. But we now are ready to put in the second branch of code. We have another control statement, or another control instruction, which is called else. And we're going to put the code we want to run if the condition is not true. We put that, big shock, inside of curly braces. So do a space, do the opening curly brace, hit enter twice, and do the closing curly brace. And then move your cursor back up in between, because right where the cursor is right now is where we're going to put the branch of code that will be performed if the condition is not true. Again, hit a tab just to move the cursor over for readability. And now let's make an alert pop up that says, haven't found the fruit. That's all. So do alert, A-L-E-R-T, your open parentheses, your double quote, and we'll type snake has not found the fruit. Do another double quote because that's the last of the message, and do a semicolon. And clearly, by the way, the semicolon, I said semicolon, I meant end parentheses. The semicolons, JavaScript's very forgiving. I keep forgetting them, and you'll notice the code runs anyway. It's just good programming practice to put them in there. All right, so I think we all know the answer to this. What is the final pop-up message going to say? Put it in chat. What is the final pop-up message going to say? Found the fruit, snake gets bigger. Absolutely. Well, let's change the snake position to 400. And let's run this. There's our first instruction. Welcome to the snake game. Second instruction, when we set the fruit position to 100, click it again. Third, when we set the value of fruit position variable to 200, click OK. And now it says snake has not found the fruit. This is pretty awesome. We have now successfully created 2 branches of code. Click OK. Inside these parentheses right here, inside these curly brackets, that's one branch of code. And inside this set of curly brackets is another branch of code. So I hope that clarifies control statements. The if and the else are control statements. And branching. The branches are what happens based on the control statement. Which instruction or set of instructions. Because look, we could have a lot more instructions inside this set of curly braces than just the one line. All we're doing right now is kind of silly. We're just popping up an alert. But in the real game, this is where you would have some, instructions to make the snake actually increase in size. Okay. All right, good. So now we've covered control and branching. Now we come to one of the funnest things, which is subprograms. I'm sure you can imagine that we are going to check this condition over and over and over and over again as the game runs. I don't know about you, but I do not want to write a game where every single time the snake moves, I have to type out this set of instructions. That's absurd, especially considering that in the real game, there's going to be a lot more instructions inside of each of these branches here. So this is a perfect candidate. This chunk of code right here, this set of control and branching statements, is a perfect candidate for what we call a subprogram. A set of instructions that can be repeated as necessary on demand by your program. That's a subprogram. So let's make a subprogram. In JavaScript, go to the very end of your code there. In JavaScript, we call subprograms functions. Different languages use different terms for this. Function, subprogram, subroutine, method. They all amount to about the same thing, which is a repeatable chunk of code that has a name where you can just call on that named function and it'll run everything inside of it. Let's build that. So you hit enter for a little bit of readability's sake. And the way you create a function in JavaScript is pretty simple. You type the word function, F-U-N-C-T-I-O-N. Notice it went blue. Our code editor is helping us. It knows this is a built-in instruction inside of JavaScript. You can hit a space, and now we need a name for our function. I think it should be called check collision because we're seeing whether the snake has collided with the fruit. Now, in general, while you can name your functions anything you want to, most programming practices say that it's good to capitalize the first letter. So we're going to write check collision, capital C, H-E-C-K, and then capital C, O-L-L-I-S-I-O-N. It's all one set of text. Don't separate the two words. That's the name of our function. When we later want to use this function, all we're going to do is type out that name, and everything we're about to build for this function will get performed. It's pretty cool. Okay, so you know how earlier when we were using this built-in function called alert, we had to give it information inside of parentheses? Well, the same is going to be true for the function we're building. We need to give this function some information. We need to give it the current position of the fruit and the current position of the snake. So when we're creating the function, the way we tell the function, hey, you're going to need some information in order to do your job, is we put that information inside of parentheses. Big shock. So give yourself an open parentheses, and let's give it the two pieces of information it needs, separated by a comma. The first information it needs is the fruit position. So type in that variable, F-R-U-I-T, capital P-O-S-I-T-I-O-N. And that's the first piece of information. Whatever the value of fruit position is at that moment will be used. Do a comma and a space, and now give us the second piece of information. That is snake position. Those are the only two pieces of information that this function we're making, this subprogram, will need. So we can do an end parentheses. So far, we've started creating a function. We've given it a name, check collision, and we've told it what information it's going to need to do its job. A variable called fruit position and a variable called snake position. Now we get to say what will happen when this function gets used. And all the instructions that'll happen go inside of curly brackets. So hit a space, an opening curly bracket, hit enter a couple times and do a closing curly bracket. And now we have a place to put all the instructions that will occur when we use this function. We know what these are. We've got them right above. So you're going to type out exactly what you see in this control and branching example, because this is what we want to have happen. So for readability's sake, hit tab. I'm still here inside of the curly braces on my function. And you do your if, parentheses, fruit position. You're just copying what you had above. And we're going to check for equality with two equal symbols. And then we're going to put in the snake position. And an end parentheses. So now we've created our condition. Now a space and a curly brace. Hit it twice. and an end curly brace. So now we have a place to put what we're going to do there. For readability's sake, hit tab. Again, this is exactly what you see above. Let's do the alert, open parentheses, and your double quote. Found the fruit. Snake gets bigger. That's all the text. So we do the double quote, do an end parentheses, and your semicolon. We've made the first branch of code. We've got our condition and the first branch. Let's go down a line, past that curly brace, a space, and the next part, the else control instruction. All the code that's going to happen on this else control goes inside curly braces. So open curly brace, hit enter a couple times, and a closing curly brace. Go back up, hit tab just for readability, and same thing. Let's put the instruction that will occur if the condition is not true. We're going to do an alert, and we say snake has not found the fruit. That's all the text we want. So we'll do a double quote and parentheses and a semicolon. So I want everybody to look at their code and answer a question for me in chat. This will take a second, but it's okay. My question is this: how many times will this alert pop up? Put your answer in chat. Iman says 1. Ludovico says once. 1 time. You're all correct. That's awesome. I deliver this class often, and a good chunk of the class thinks it'll happen twice. They think it'll happen the first time here, and think it'll happen the second time here. Now, you all got it right. Those of you answered. So I'll just clarify why it won't appear a second time. It happens here. Let's go ahead and run it. Go ahead and run your code. There's our first one. We're used to seeing that. Click OK. There's our second one for fruit position 100. Click OK. There's our third one for fruit position 200. Click OK. There's our fourth one, which is for this control and branching example. Click OK. And that's it. It doesn't appear. Here's the exact reason it doesn't appear, and this is critical. We made a function here called check collision. We specified what information we'll give it. We specified what we're going to do, which is we're going to execute this if-else chunk of code. Everything inside of these curly braces. But all we did was define the function. We never asked it to run. To do that, you have to specifically say, please run the check collision function. So let's do that. Let's set it up with some new data. Let's set up our variables. Let's say that right now the fruit position, type out your variable, and let's say it's equal to 50. And let's say that the snake position is equal to 51. It's right next to it, but it hasn't hit it yet. And now we want to check whether or not we hit the fruit. So we're going to call on this. That's the phrase you use. The verb is to call the function. We're going to call the check collision function by simply putting in the name of the function, check collision. And don't hit a space, do a parentheses. And now we have to give it information. And what we're giving it is the two variables. More precisely, whatever the value of those variables are at the moment we call the function, that's what will be used by the function. So let's type in our two variables, our fruit position, comma, space, and our snake position, comma, space, and put a semicolon, and we're done. Now, what will the final alert say? Put that in chat. What's the final alert going to say? Snake has not found the fruit. That's exactly right. Now, what if I do that? What will the final alert say? Found the fruit. Snake gets bigger. Let's run it. Make sure that you changed it to 50 like I did. Hit run. Yep, found the fruit. Good job, George. All right, there's our hello. There's our 100. There's our 200. The next one is this chunk of code right here, our first control and branching. It's not the function yet. So we click OK. Hey, snake has not found the fruit. Now we click on it, and boom, found the fruit. Snake gets bigger. So if we go to the end here, let's change the snake position. And say it's a long ways away. And let's run the check collision function again. Check collision. And give it the information again. Fruit position. Snake position. Ooh, Ludovico, I'm going to get that question in a second. That's brilliant. Let's run this again. And the final one should say that we have not found it. There's the hello. There's the 100. There's the 200. There's the control and branching example. Here's the first time we call the function. It says found the fruit. That's right here. It's because they're both 50. Click it again. Snake has not found the fruit. That's because the snake is over at 200. All right. Last question. I'm going to answer a question here before we show you the full code. Okay. Ludovico has a brilliant question. He says, can I write inside the check collision function, inside the parentheses, a specific value to set the variable to that value? I'm going to show you what he means. He's saying, can I do this? I want you all to follow along. Check collision. And in parentheses, can I do 50, 51? Well, let's run it and find out, everybody. There's our first one. There's our 100. There's our 200. Here's the control and branching section. Here's the first time we call the function. Here's the second. And now the last one. Boom. Snake has not found the fruit. Absolutely, you can do that. Now, Ludovico, I want to clarify something. He said, can I write inside the check collisions parentheses, that function's parentheses, a specific value to set the variable to that value? And this is important. The variables, snake position and fruit position, are outside of the function. So when you put 50 and 51, you're actually no longer using the variables at all. It doesn't change the variables at all. It's just giving the check collision function information it's capable of using. All it needs is two values. It needs two number values. It doesn't matter whether you type them in like this or the values came from a variable outside of the function. It's data, and the function will run. That was a great question. Yes, only checks for the value, not the variable. It's exactly right, Ludovico. That was a brilliant question. The value of the variable still remains the same after the function. You're absolutely right. And by the way, there's a lot of nuance there about what happens inside the function and what happens outside of it. And it is important to know. It's beyond the scope of this class, but I'm really glad you brought that question up. And I will say that on our boot camps, you learn everything about how that works and how to use it to your advantage to make very highly functional and valuable programs. That was a great question, Ludovico. All right, now let's look at the whole code. Oh, what about the fruit position and snake position in the function code? Is that another variable? Oh, Will, brilliant question. He says, what about the fruit position variable and the snake position variable inside the function? Is that another variable? Yes, it is. That's brilliant. We could call this f and this variable s, and then we can say is f, don't follow along with this, equal to s, and it will still run. Run your code. First one works, second one, third one, fourth one, fifth one, sixth one. The function works the same. That was a brilliant question. These variables, when you make the function, are only used inside the function. Or rather, the value of them is used. Because remember, from the outside, we're taking a value and passing the value in. That's what we're passing in. Now, again, that's a little bit beyond the scope. It was a brilliant question. And the fact that you asked that question means you're thinking like a developer. That was awesome. All right, now let's take a look at the real program. I'm going to drop, actually, if my assistant can drop a link in chat to the full code, go to that document that opens up, copy and paste all of the code, and then go into your editor, highlight all of the code, and paste to replace it. You're going to replace everything inside of the code editor. And you'll see what I see right now. This is your full game. And you can run it. Now, I'm going to make my screen smaller. You won't be able to say it play, but I'm going to click run. And there you are. You have to click over on the game board. Make sure you put your cursor over here and click on the game board. And now you can use your arrows to control your snake. So I'll let you all play that for a minute. Ooh, I did it. Okay. Hey, I got the snake. Hey, got it again. Give yourself a few minutes to play with it. All right. So that's how the snake game works. Now, let it play, and let's look at this code for a moment. Now, a lot of this, there's a lot on here, and I want to stress something. Any graduate from our program will be able to read through this and understand everything that's going on. For right now, I'm going to give you some highlights. There's a lot of HTML in here. You can see HTML here. You can see some things like a title. You can see a bunch of other stuff. What we care about right now for the program, the snake program, begins at this script tag. If you scroll all the way down towards the bottom, you'll see a matching /script. Everything between those two things, this is your program. I'm highlighting it for readability's sake. That's your program. Now, two things. One, you'll notice this green stuff, this little symbol right here of 2 slashes. In JavaScript, that means put a comment in the code. Comments are not instructions. They don't make the computer do anything. They're only there for you, the human being, to read and get some more understanding. That's all they're for. Everything else, this is actual instructions. You can make some variables here. There's a type of variable called a constant in JavaScript. You have some functions. Look at that. We have a function called setup. And you can see that's the first thing we do. We set up the game. We make a snake. We make a fruit. We put the location of the fruit at a specific spot on the game board. And then we have a loop that keeps track of the position of the snake and the fruit. It draws the fruit, updates the position of the snake, and draws it. You can start to see the patterns that we've studied during this class shown here. You have if statements. If the snake eats the fruit, then pick a new location for the fruit. There's a control statement, isn't there? Here's a function called snake. Here's a function called updating the position. This is how you update where the snake is. Every millisecond or so, we're moving the snake as I move the arrows around. Say I click down and it changes the snake position. So you could read through this code, and it might take you a little while, but just based on what we studied today, you have at least a rudimentary understanding of what it's doing. On our boot camps, you learn to program this and lots of other kinds of things. All right. Now, let's talk about Q&A. Let me switch here for a second. All right. Now, we went a little bit over. That's on me. So here's how questions will work, because you may very well have questions, and I love to hear them. I'm going to give you an email in a moment where you can actually send in your questions. We're going to use that email for a few different things, including the free gift. But I want you to keep track of your questions. You can, in fact, put them in this email I'm going to give you, and they will get sent to me, and I'll reply. I love seeing questions. I love answering them. So let's move on. Okay. Now, I want to spend a moment here, and don't go anywhere because we got your free gift coming, okay? And special links and a bunch of cool stuff. I want to talk about the school. Now, I understand that not everyone who's attended this class is like, oh my God, I need to do a boot camp. I loved this coding thing. I want to break into tech. But for those of you who are at that point, who are like, man, I rather enjoyed this. I really like the idea of going into technology. I have a few words for you. The first is about our boot camps. We have 12 online boot camps. They cover a wide range of technology subjects. They cover artificial intelligence, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development, and more. In fact, we have more certification programs than any other coding boot camp on earth. Our boot camps have the following characteristics. They're self-paced, but they're also instructor supported. They're flexible. Students set their own schedule, and they can enroll 365 days a year. The content that's covered in the boot camps is well-rounded, and it's in-depth. Also, our boot camps are affordable. They're priced under the national average. And all of our programs include both job placement training and job placement assistance from really competent job placement experts. Most importantly, our programs are designed for absolute beginners. No technology knowledge or prior coding experience is required, so you don't have to be a nerd to get through these programs. It does help to be a nerd because then you get a lot of my stupid jokes I tell in the curriculum, but you don't have to be a nerd to get through these programs. We consistently land on every major best coding bootcamp list out there. So a lot of places to track this, and we're always at the top of the list. Our average review rating across all major bootcamp review websites is 4.8 out of 5 stars. We're super proud of that. And this is based on student and graduate feedback. This is what people say about us. It's nice. So I've got a couple questions, like why would you consider working in technology in the first place? First of all, tech does have a really good work-life balance. You don't work 60, 70, 80-hour weeks in tech. It's not that physically demanding, which can be a good thing or a bad thing, right? But it's a really nice work-life balance. Also, the possibilities for remote work are very big. As a knowledge worker, part of a well-functioning team, you can work remotely really easily. It's also a very creative industry. It isn't boring at all. It's the practice of creating useful software to help people accomplish useful work is a collaborative, highly it's a task that requires a lot of communication and collaboration. It's really cool. And you take a lot of personal pride in your work when you or your team push something out there that people find very, very valuable. It's also a very stable industry. It pays well. And in tech, there are regular increases in pay. The ceiling is very high for pay in tech. There are, however, barriers, particularly for the route we're talking about, which is a boot camp. Boot camps, money-wise, they cost a lot. The tuition can be in the thousands. Now, what we've done is we provided multiple financing options. We do, in fact, have an upfront discount. If you can afford the full tuition upfront, you get a big discount. We also have monthly payment options. If you have no credit or bad credit, there's a tuition option for everyone, no matter what your financial condition. But the fact is that doing a boot camp at the school is an investment in yourself. You're giving yourself extremely valuable skills in an industry that is not going away, pays well, and has long-term prospects. Let's talk about time. There is a required time investment to get through a boot camp. There's a lot to learn. Some boot camps handle this by putting you into a cohort. They gather a bunch of people who want to go through, and they all start on the same day, and they all move through the material at the same pace. I don't like that model for a lot of reasons. Some boot camps require you to attend in person. Here at the Tech Academy, all of our programs are online. You choose your study schedule. That means part-time study schedules are allowed as long as you're putting in sufficient amount of time to get through. And it means you can study concurrently to doing your job or going to school. And finally, let's talk about technical interest and ability. Some of you have felt like tech isn't for you because it's made to be so unapproachable. A lot of tech education materials are too hard, and the primary reason is some educators assume too much prior knowledge on the part of the student. With the Tech Academy programs, you don't have to be a nerd. There's no tech background required to be able to enroll in our programs. And I hope you've seen from the way we approach this subject, we make it approachable for anyone, no matter where you start your learning journey. So I have some questions for you. Are you working a dead-end job? Is there a ceiling for you income-wise that you can't ever get above? Or maybe even unemployed? Do you have a strong desire to work at home? Or do you want more time with your loved ones? The central question I have is it time for a career change for you? If so, the Tech Academy is the solution. We are career change experts. Our logo is a bridge on purpose. We want to provide a route into tech for everyone. We want to bridge that gap between the population and technology. And at this point, we have a decade of experience breaking people into technology. And it's successful. Most Tech Academy graduates make $30 an hour on average in their first job. Do the math, that's $60,000 a year. Now, not everybody gets that right out of the gate. That is the average over 10 years. And that's a great salary to begin with, and it only goes up from there. At this point, we have over 1,000 graduates working in tech. And they work in all kinds of outfits, from small businesses to the big guys like Facebook, Disney, Uber, Epic Games. And as a reminder, we have open enrollment. There's no batching and cohorts. You can start anytime. So I encourage you to start now. Enroll now. And here's how you do it. You go to this link. We're going to drop that in chat. It's the Erik link. And when you go there, there's a simple form to fill out. And that'll let you access a series of steps all about the Tech Academy. So you can learn for yourself and make an informed decision. You'll find videos, articles. So there's even an optional step to book a call with our admissions staff. So after the event, please complete those steps and look at it and see whether it's for you. So fill out the form though right now. I'm going to pause for a moment. I also need a sip of water for you to fill out that form. It's real brief. It's a few fields. And by the way, if you go to that link and a login form appears for you, that means you already have an account with us, and you can see details at the bottom of this screen on how to log into your account if it already exists. All right. Now, since our graduates love us, and they do, it's really nice to hear from them. Referrals are one of the top enrollment sources for our company. Because of that, we offer a 5% commission payment for all enrollments. That's not restricted only to our graduates, though. They do often refer their friends, but it's open to you. When you email in, and like I said, we're going to give you an email address in a moment. When you email in for your upcoming free gift, you can also include the name and contact information for anybody you want to refer to the school. We'll keep track of that, And if they enroll, we'll send you a check for 5% of the commission payment. Or for 5%, sorry, for 5% of their tuition payment. Now, we have 7 publications at the school, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, a technology basics dictionary, a project management handbook, and You Are Not Stupid. I want to expand on that for a moment. You Are Not Stupid is essentially a written version of our most popular course on all of our boot camps called the Computer Basics course. This course removes all mystery from computers and technology. All the modern technology terms and concepts are defined, and the book even includes a history of technology that shows how we arrived where we are today. This book is fantastic for you, but also, I was just talking to a friend the other day. If you are the person who is the go-to tech support person in your circle of friends or your family, if your grandmother's always asking you to handle things on her phone or her computer or whatever, get them to read this book. It's tremendously stabilizing, and you won't be tech support for your family anymore, which is pretty cool. All right, here's our free gift. It is our Introduction to JavaScript book. It's called Learn Coding Basics in Hours with JavaScript. It's really good. It also expands in some detail on those 5 elements of any computer program that we discussed in this class. Now, this free book, and it is a book we're going to send to you, unfortunately, it's for students in the United States only. And here's how you get it. Put your full name, and don't forget to put your address in there, your full mailing address, in an email. There's the email address right there. We also dropped it in the chat, books@learncodinganywhere.com. If you'll send your name, an email, and mailing address in, we'll send you a copy of this book. Here is also where you include any questions about the class that I didn't get a chance to answer, and any referral names and their contact info. Put that all in that email, and we'll take care of it. So I'm going to wait one moment for people to fill out that form if they'd like. All right. Now, I know we dropped some of these links already. I'm going to give you the full story in our links. We put all of our links for the school at one location. We use Linktree for that. We're going to drop this link in the chat. And when you go to our Linktree, you'll find all sorts of links to our free educational YouTube video playlist, to our books and our dictionary, upcoming meetups. If you want to do more of these classes that are free, you'll find the links in there. And of course, links to all of our social media accounts. So please follow us on social media and invite your friends to future meetups and tag us when you do that. So that link should be, in fact, we're going to put a link to our next event in chat. And finally, here's a pretty cool opportunity. If you'd like a chance to win your own copy of You Are Not Stupid, there's a way to do that. And this, look, obviously, Jack and I wrote this. We're kind of biased, but the reviews on this book are phenomenal. We put a year and a half of concerted effort into this book. It's very good. If you'd like a chance to win your own copy of this book, here's all you have to do. Get the link to our next event, share it on your social media, and tag us. Any platform that we're on, just tag the Tech Academy and link to our next event. If you want to see something, anything that you enjoyed about the class, that'd be fantastic. Anybody who does that, we enter them into a hat, and we pull a name out of the hat at the end of the week, and we will send you your own free copy of You Are Not Stupid. So I want to thank you all very much for attending. I want to remind you, if you filled out that form, and the link is here again, if you filled out that form to learn more about coding boot camps, make sure you do the steps after the form. Watch those videos, read those articles. If this is at all of interest to you, you owe it to yourself to find out as much information as possible to make an informed decision. And I'd really like to see you at our next event. And our next event is this evening. It's our 10-year anniversary celebration. Please arrive. It's going to be a lot of fun, and we have a phenomenal announcement. And other than that, I'll just see you when we see you on these events. I'm glad you were here.